All right, we're going to be talking about the Zero Energy Ready homes, DOE Zero Energy Ready homes version 2. And before we jump into that, talk about thanks to our sponsors, Rheem. Rheem has heat pump water heaters, which are the future of water heating. They take natural heat out of the air, use it to heat water with zero emissions, directly up to 400% energy efficiency. They offer a hybrid water heaters with backup electric resistance at 240 volt to ensure hot water all the time. And they have 120 volt systems that quickly replace older gas furnaces without the expensive electrical upgrades. These work by pulling heated air through a filter and it's absorbed with a R410 refrigerant, using a compressor to heat coils wrapped around the tanks. You can control your system by heating levels, sense leak detection, track energy use over time, and set up a schedule for time of use peak load shaving programs. We're going to be talking about the Inflation Reduction Act today for sure. And for existing homes, there are some goodies out there, a little bit different than we're going to be talking about today. $2,000 tax credit up to $2,000 or 30% of the cost for heat pump water heaters, and $600 potentially for the improvements needed to the electrical systems to get it done. Now, you might be saying heat pump water heaters are too expensive. They won't fit my client's home. But we still will hope that you'll consider going all electric. And so now they're standard tanks, which are pretty energy efficient, well, not as energy efficient, can be set up for on-demand response time of use programs to help only heat water when the peak, less carbon on the grid, less cost as well. So you can check those out. All of their products there at rheem.com, heat pump water heaters. And then also thanks to our second tier sponsor, Niagara Conservation, with low flow water. They are a 2022 eco leader for green builder media. Again, these go down to 0.8 gallons per flush, potentially even down to 0.5 gallons per flush for their dual flush toilets. I've had one for a decade now, works great. Vacuum assisted technology is going to make sure these systems flush, keep water low. Hey, if you're really nervous about that low flow, they have toilets all the way up to 1.28 gallons per flush, still compliant with the green programs as well to help you achieve your goals. So check them out at Niagara. All right, so again, with that, excited to be going over the Department of Energy's Zero Energy Ready version 2 program. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We're a very small staff of 3, and today I will be your moderator for this course. I am the education manager here at the Green Home Institute. And just like many of our courses, this one is approved for multiple continuing education units, as well as Certified Green Home Professional in Energy Health Materials, and also the AP Homes credential. It's also approved for AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license, as well as Passive House Institute US FIAS. You'll receive your 5-digit code upon completion. Before we get into the course, I have a couple introductory things before I hand it off to our speaker who's going to take you from here. Like I said, this session, unlike most of our sessions, is going to be roughly 2 hours long. It's approved for that many CEUs, so we hope you can stick around and continue to engage with us through conversation. We'll also have some time halfway through for questions, and then again, questions at the end. So before we go too far, I just want to remind everybody that there are baselines to achieving the DOE Zero Energy Ready, and we're going to discuss those baselines almost like a ladder that you climb up, right? You need to achieve one program before you achieve the next, before you achieve the next. And so on our YouTube channel, we have a whole series starting from what you need to know about the energy rating systems and going on down from there, Energy Star certification programs, the water management program, as well as the Indoor Air Plus program. And then also, again, how to do modeling to achieve the Zero Energy Ready goals. And so really, if you're starting from nowhere, we're glad you're here. You don't need to leave because I believe we're going to give you a lot of foundational knowledge. But if you want to get into this, you might want to start to understand all of those programs from the beginning. And we'll be doing updated sessions as new versions of like Energy Star come out. And on that note, I wanted to give a shout out. Indoor Air Plus is upgrading to version 2, and public comment, I believe, is open until April 3rd. So you can go in now and read what it will most likely be. But hey, maybe you have some ideas on what you want to see Indoor Air Plus be. Maybe you have something to add to the conversation. And also that's going to impact achieving the DOE Zero Energy Ready program and achieving the Inflation Reduction Act dollars if you're trying to get those. So go make a comment and go learn about that now. And then also, as a reminder, in order to get Zero Energy Ready certification, you need to be collaborating with an energy rater, a certified energy rater. There's 4 different entities. 2 of them are special in the country of California, if you will. And then the rest are national. And so you need to collaborate with one of these certified raters through one of these entities, depending on whether you're in California or national. And then also typically the builder needs to be certified as well, though that's a much lower bar than the rater, and we'll talk a little bit about that too. Now, if you're utilizing these programs for the green certifications, such as LEED, one thing you'll note is that there is an addendum that had been issued several years ago through LEED that basically automatically grants 15 energy points to anyone who achieves the Zero Energy Ready certification program. And on top of that, they also grant several prerequisites that get met automatically just by achieving this certification, as well as additional points. So minimum energy performance, superseded, right? We meet that. Education of the tenant building manager. There's a component of that built into Zero Energy Ready already. The efficient hot water distribution system is built right into the Zero Energy Ready certification program. Active solar ready design. That's what this program is all about. Having that credentialed HVAC contractor, again, the energy use, and then also you get an innovation credit just for achieving this. So there's multiple points there. And there's a few more as far as Indoor Air Plus, which we'll get into. But it's also important to remember that most teams are doing better than this 58 when they're achieving Zero Energy Ready certification. In fact, now we're seeing a lot of teams really get down to this 40 level on the HERS rating, if not sometimes lower, before they add solar to their project. And so make sure you're checking the annual energy use performance calculations, because you might be eligible for more than just 21 or 15 points in energy. You may be getting more if you're in line, especially with this newer version of DOE Zero Energy Ready, where you might be getting in the program for LEED with your HERS index ratings. Now, like I said, Indoor Air Plus is required for Zero Energy Ready certification. And so Indoor Air Plus already checks many of the boxes for LEED. It checks all of the prerequisites and compartmentalization, most likely on multifamily. And then it gives you credits in all of these other sections: contaminant control, balance of heating, enhanced combustion venting, enhanced garage pollution, low emitting products, I believe is in there, and then environmental tobacco smoke. So you're talking about 12 points right out the gate, again, for achieving this program within LEED, which yields you roughly 23 to 29 points out of the 40 required just to certify in the LEED program if you're going DOE Zero Energy Ready. So 2 things to think. First of all, you're getting more than half your points to certify, but it's also important to know that LEED is an above energy program. It expands way beyond energy. And so that's why, again, you might do all this work for Zero Energy Ready, but you still got more work to do in the other categories of LEED certification. And so that's really how they tie together. And we'll discuss that a little bit more as we go throughout the session. If you are doing enterprise green community certification programs, such as for your low-income housing tax credit projects, one thing you'll note is that you'll probably achieve 27 out of the 40 points for new construction or 35 for major rehab by achieving the Zero Energy Ready certification. And you also qualify for the Green Communities Plus program, which in the state of Michigan and maybe other states now gives you bonus credits in your application to achieve the massive tax credits from the state for the low-income housing tax credits. So it's really a 2-for-1 pursuing Zero Energy Ready certification within your Green Communities criteria submission. Finally, if you're using our internal Green Star Home certification program, we have built out for you a sort of automatic checklist here. When you go, you will find anything that is Zero Energy Ready automatically pre-qualifies for all these credits. We're also building that out for Indoor Air Plus because there's more of them. And so you'll see you pre-qualify for a lot of these items. Radon really depends on if you're in zone 1 or not, because we are a little more stringent on radon than Indoor Air Plus. And so there's just a couple more things you got to do to certify. And so we have that all built right in for you within the Green Star program, if you're looking to do a dual certification with that. So with that, I am super excited to have our speaker today, hand it off to him, Armando Cobo, and he is a residential designer in Texas who has a lot of experience with this. And so I really appreciate his time. And Armando, welcome, and please take it away.
Brett, thank you. Thanks, everyone also for joining in. And I'm pretty excited about making this presentation for Zero Energy program. The version 2 DOE has not come up with the education material, but this is a PowerPoint presentation that I put together with the new information, and also it was reviewed, and I want to give kudos to Jamie Lyons at Newport Partners for reviewing it with me and clarifying some suggestions. So anyways, having said that, we got a lot of slides to cover. So let me share a screen. Can you see it, Brett?
There it is. I see. Well, I see all your slides.
Yeah.
So,
yeah. Okay. So here, hold on. Sorry. Okay. Are we there now?
There it is.
Okay. So my presentation slide actually is to tell folks that you can design a zero energy home for any climate zone, any style, any size whatsoever. Fortunately, for version 2, they took out the size adjustment factor. So now we can certify and register houses that are fairly large. So what the program is all about is about energy efficiency, greenhouse gas reductions, indoor air quality, comfort, moisture management, renewables, and electric readiness, which is the new a big part of the new version. It also recognizes high performance. Now with the tax credits that just got passed a few months ago in Washington, all the tax credits got extended, not only for new construction, but also for retrofit. So we'll talk briefly about all those things. It also talks about innovation. I mean, then, we get a chance to come up with new products, new ideas, new systems, new things. So one of the good things that I like about the Zero Energy program is that it basically says you need to do Energy Star, and then you need to have a minimum HERS score. You need to have a minimum envelope tightness, and that's it. From then on, you're on your own how to get there. That's why I like this program better than any other one. So having said that, we're still looking for a better environment, a healthy environment. We're looking for more comfort. We're looking for advanced technology, being more efficient, have better quality homes. And of course, better quality homes means more durability. So we're trying to start with the existing stock that is right now is pretty low on performance and efficiency, but we're trying to move the needle up and up and up, like most green programs. But I think we have a really good system with the Zero Energy home. Last year, there was almost 12,000 homes certified to the Zero Energy Ready program. ResNet has come up that there's an average of about HERS 58 for all the scores, and Version 2 is now requiring to be in the 40s. So, but it's still, we can tell that new homes are getting better and better as we're improving the quality of the homes. The Zero Energy program is basically designed for single families and duplexes, townhomes. That's what it is so far right now. As far as manufacturing homes and as far as multifamily, the programs are being developed, the guidelines are being set up, and so forth. So we're basically going to concentrate on the movement from Energy Star version 3.2 to version 1 of the Zero Energy program, and then also for now the version number 2. So we'll hold on manufactured homes and multifamily versions when they come up with those programs, and they'll have their presentations ready for that. So as we know, different versions are being applied today in some states. Different codes. I mean, we just finished a house in rural Illinois that it was this part of the country is in the 2006 code. And so trying to do a zero energy home, we had to make sure that we were at least applying the 18 code. And so having said that, we can tell that version right now for this year, any home that is certified, it needs to be in version 1, revision 8. Any program that the building permit is after next January of 24, then it needs to automatically go to version 2. So there's also similar requirements to California, and right now we know that the HERS score required for version 1 is somewhere in the middle of the 50s. And we're improving somewhere to the middle of the 40s, from low 40s to high 40s. And so it makes it easy to get there. People that, as Brett said, that some of you guys are already in the 40s. That's excellent. I vouch for people that do those kind of things, because actually just doing the right thing, just sealing the envelope like we all supposed to do, regardless of what construction we're doing, you pretty much can get a HERS 40, and you pretty much can get below 3 air exchanges of 50 pascals. So just doing the right thing, we can get there. One of the good things about the Inflation Reduction Act that got passed a few months ago was that the old version, we had tax credits for energy efficient homes, and we also had tax credits for solar and renewables and so forth. Everything got extended 10 years. So there's no this thing like we had in the beginning that it was only a few years and then it had to be renewed, and then another few years and it had to be renewed. So at least we know that we have 10 years for a full tax credit, and then it kind of fades away in year 33 and year 34. So we know that for new homes, you can get up to $5,000 and $2,500 for Energy Star and retrofits. And so this is going to the builders. And so this is separate to the credit that goes for renewable on renewable energy, the solar panels and so forth. That is totally a different credit. So how we're going to get there? There are some mandatory requirements, just like most programs. So we need to know that we have to go to version 2. We also have to certify our homes to the Energy Star version 3.0. And I believe that I sent all this requirements to Brett to share with you guys. As far as the envelope, as you well know, the 2021 code has increased energy efficiency by quite a bit. So if you happen to be in the 15 or the 18 code, it's it's a step up, but it's very doable. If you're in the 2006, like the house we just finished in Illinois, some other parts of the country don't have any code, or are 2009 or 2012, it's a biggest step up. So you're going to see that now you're going to have to increase the insulation and outsolation on the walls. You're going to have to also increase in the attic and the requirements that goes whether you do a conditioned or a non-conditioned attic. The duct systems needs to be inside the conditioned space. Water heating, now there's requirement also for electric water heaters and also heat pump water heaters, or at least have a free an area, design an area for heat pump water heaters. Yeah, go ahead, Brian. I can't hear you.
You're saying it has to be electrification ready?
That is correct.
Okay, but heat pump water heaters and stuff won't be required per se, right?
That has to be, and we'll see this later. So just give me a few slides, and yes, we have to have an area designated for a heat pump water heater, to be added into a house. If you're using gas, if you already have electric, you're okay.
To like fit it in and have enough volume exactly there. And interesting. Okay, well, continue on. Thank you.
So also the lighting needs to be 100% high efficacy. Indoor air quality, now we're including Indoor Air Plus into the equation, using ERVs. And of course, as far as I'm concerned, every house I design, it has ERVs and or HRVs, and also dehumidification. If you happen to be designing a house and building a house in an area where there's high humidity, and especially in the shoulder seasons, when you don't have the air conditioning controlling the humidity on the house, to have an independent, separate dehumidification system on a house is a big plus. So renewable ready needs to be done there. You need to have also at least one electric vehicle charger ready for it. So those are things that we need to start thinking about it as you add to it. Here's the heat pump water heater ready that you need to have in a home or in the garage, an area specific for a heat pump water heater if you need to install it in the future. Again, also the HVAC system, it improves in efficiency, it improves in how much SEER or heat pump efficiency, the boilers and so forth. So all this requirements were, I believe that the PDF was sent to Brett, and he should share to each one of you. And if not, obviously you can go to the Zero Energy Program website and download all the requirements that needs to be done. Again, insulation also is improved tremendously. You really need to pay attention on that, because now pretty much everybody's going to have to start using outsolation or rigid foam on the outside, continuous insulation. So, or at least that's one of the options. But I just don't see how in climate zones 4 and above, and R20 wall insulation, it's good enough without any type of condensation. So we'll see how people react to it and what the solutions are. But even for my designs, anything from climate zone 3 and above, we're using 1 inch of rigid foam on the outside. So just take a look at that, because that is a big improvement there for some of you. The windows, again, it's also improving in U value, and solar heat coefficient, it goes lower for the lower climate zones. Fortunately for folks in climate zones 5 and above, there's any requirements for solar heat gain coefficient. Doors are also specified what needs to be done. Here down below is water heaters for electric water heaters. And even if you still want to use gas, there is efficiency improvement for water heaters. All ducts in the conditioned spaces, and as I said, also lighting and appliances, it's all 100% low efficacy. So in a nutshell, what is it that we're trying to do? We're trying to improve the building envelope. We're trying to improve moisture protection in a house. We're trying to improve comfort. We're trying to improve better indoor air quality. That is a huge thing. We know that for the last 20 years, the rate of asthma in children has doubled. So that is a big thing. Efficient components on the rest of the house, and then of course solar ready. So what we're doing is we're taking the Energy Star 3.2, we're getting to a tighter building envelope, and we'll see how tight we need to go in a minute, but we need to improve performance, and then we come to zero energy. That's how we need to do. We need to do a continuous air barrier, insulation barrier, thermal barrier, all that, all the way around the house. Again, the water protection, we need to make sure that we deal with better products, better systems on how to use it. Pretty much every single house that I'm designing right now, we're using rain screens. There's different options for different products. I've always said not every good product is applicable to any installation. So make sure that you married the correct product to the correct rain screen that you're trying to use. Whether we use stucco, you may want to use Benjamin Updike's rain screens. When you're using siding, obviously you may want to use, say, 1x4 rain screen. So all those things, it just needs into account better sealing, better waterproofing, better management. Again, appliances. We take Energy Star appliances. We use ceiling fans, exhaust fans, water heating. All this, we're going to do a much efficient equipment. We're going to add lighting. We're going to have hot water distribution. This is a big thing too. Now we're going to have to start either bringing all the rooms that have water use, like bathrooms and laundries and kitchens, as close to each other, and hopefully, we can use, say, for example, a manifold. So we don't have to, in big houses, we don't have a choice. Sometimes, we have to put recirculating pumps, and so then that becomes now an issue. Is what water heaters are we going to use? What water heaters work with water pumps, and do they need to be on demand or are they not? And so it now it becomes that we're going to have to start thinking about what systems we use on the house. Same thing when it comes to the renewables, whether we're using solar panels, whether we're using solar tiles, whether we're using battery systems, whether we're using generators. Not all batteries can be charged with a generator. Not all batteries are some you have to replace them every 7 years, some you have to replace them every 10 years, some cost $5,000, some cost $20,000. So all those systems need to be done. What type of panels you're using on the house, if you're using a smart panel or not, if you have to use automatic disconnects or so forth. All these things needs to be thought out ahead of time. I actually have a thing that I try to talk to my clients, the homeowners and the builders, and is that before I start drawing a line on AutoCAD, I want to know what systems we're going to use on the house. It doesn't have to be 100% accurate, but then that gives me an indication. How am I going to use, what type of wall assemblies I'm going to use? What type of roof assemblies am I going to use? Am I going to use floor trusses? Am I going to do a basement? Am I going to do a conditioned crawl space? Am I going to do a conditioned attic or a ventilated attic? All those things, I think it needs to be settled before you start designing a house. I see so often people bring in a set of plans and they want me to green it. And at this point, it's hardly impossible or expensive to do. I mean, folks are thinking that if you need to start planning for floor trusses with dedicated chases, so you can have a trunk and branch system, which is a lot more effective, a lot easier to do. Think about all these things way ahead of time. So when you know that when you start designing the house, you know where you're going to have the mechanical system, you know how you're going to run the system, you know that after that it comes the plumbing. Then after the plumbing, it comes the electrician, because those guys can go whatever they can a lot easier than the HVAC system and the plumber. So think about all the systems way ahead of time so you know what to do. One of the things that I really like about the zero energy home is that they don't require what wall assembly or what roof assembly you need to do. All you need to do is make sure that it works for the program. And so this is where we're moving from and to. Obviously, Energy Star started back in the late 90s. Energy Star 3.2 was just recently Zero Energy. They started about 10 or 12 years ago. Now Energy Star 2, this yellow boxes is where we need to improve. Now we need to move to a building enclosure on the 2021 code. We also need to have a HRS in the 40s. We also need to have dedicated hot water distribution already in the plannings. Heat pump water heater ready, as I mentioned. There's this other requirements about PV checklist. We need to have at least one EV ready for electric vehicles charger. And we're doing a house right now where the homeowners, they want 4. So you need to think about that, because each electric vehicle charger is going to be drawing somewhere around 4 kilowatt hours. And so not that you're going to do it all at the same time, but there could be the possibility that at some point you may need to. So you need to have all the power that goes to those requirements. So high efficacy on lighting, also heat pump space ready. We're basically switching. We're trying to avoid using gas, and believe me, that here in Texas is a big deal. So, as you well know, gas is king down here, and they're trying their best for us to keep using it. But anyways, so we need to have Energy Star appliances. We need to have higher performance windows, and as I said before, there's no square footage requirement anymore. So envelope air tightness, and how do we get there? The thing that we know is that there's a lot of air leakage that goes in and out of the envelope on the house, in the attics, in the walls, all the openings, windows, doors, crawl spaces, basements, and so forth. We need to address those things. Now, as Brett said, that we need to start working with verifiers. And these verifiers, not only they're going to take your initial floor plan and the specifications, and based on the details and the specifications that you have in there, they're going to have to analyze the house and come up with a design HERS rating. That is critical. That is important, because that is what starts the verification process of your house as you build it. If a typical house, by the time you get it all done, it's somewhere in the neighborhood of 3 to 5 air exchanges or 50 pascals, they're going to be able to use, the big fans on the blower door test. If your house is in the less than 1 air exchange of 50 pascals, a normal size of a house, they normally use a duct blaster to pressurize the house. But at the same time, they need to verify and make sure that the ducts have, the requirement for air tightness. They need to make sure that you have the required airflow coming into each one of the registers. That's why it's so critical to design the HVAC systems with all 4 manuals. That means even the code requires SD and T or SD and J. You also need to think about using T, because having the terminals, all the supply registers, and the return register are just as important as any duct or any size of the equipment. And so that is something that in my projects, we try to hire folks that are professional at designing HVAC systems. Homeowners know that it's a cost that is added to the project, but at the end, in the long run, it's going to save them money. And I know with confidence that I can have a system that is designed properly. And then at the end, I'll show you what are typical specs of a house. But the worst case scenario, if you do things right, the worst case scenario, you're using about 1 ton of heating and cooling per 1,000 to 1,200 square feet. That is worst case scenario. Okay, so think about that. You can go. Usually we're around 1,500, sometimes a little bit more. I've heard guys, using 2,000 square feet per ton, which I think is great. Sometimes the problem is within the design. I happen to design mostly large houses, and so if we have manual J says that we need 2.2 tons. Obviously, we use high-end CEUS equipment, and so we have to go to 3, unfortunately. So there's one of the things that happened that I wish manufacturers would do half tonnages. I happen to like heat pumps. I happen to like. I don't tend to like, especially on these big houses, putting ductless mini splits is just nobody's going to go for that. The looks of that is just it doesn't happen. We use it in specific rooms. We use them in gyms on a house, or pool houses, or storage areas, that kind of stuff. But typically using a ductless mini split on a $5 or $10 million house is just not going to go in a family room. So anyways, so what are the options that you have? And here we're going to show different typical walls styles that are used around the country. Doesn't mean that those are the only wall sections that you can use, but probably the most common one is 2x4, 2x6, 24 on center, using rigid foam insulation on the outside. You can also use 2x4 stagger studs on the 2x6 plates or 2x8 plates. You can use insulation in the exterior sheathing. In other words, having continuous insulation is the way to go. You take a 2x4, 2x6 wall with just insulated on the inside. By the time you add the framing factor, instead of having an R20 or R21 wall, you only have an R14 or R13. So having continuous insulation, it will add anywhere from R4 to R7 on the outside of the whole assembly. So this is the typical insulation that goes into a 2x wall, whether it's a 2x6 wall here. And as it says here, the framing factor, it just reduces the R value of the wall. Another common way to do it is to use structural insulated rigid foam. It allows to have that rigid foam on the outside, but then, as you will know, you need to have some bracing included into this wall, which adds labor and so forth. I happen to like the system that is the rigid foam on the outside of the sheathing. Some folks, and it's becoming popular, using products that have the rigid foam inside of the rigid foam. But to me, structurally, I just feel better. I sleep better. And having the outside of the OSB or plywood on the warm side of the wall. Also, using structural insulated panels is a common system. I don't use it hardly ever. I tried for a few years back. You really need to use a specialized, it's a good system, but you need to use a specialized installers, guys that know what to do, guys that have dealt with the systems for years, day in and day out. Any type of leaks, it becomes a big issue later on. And so to me, it is a good system, but you really need to use people that specialize in the design and installing the system. The same thing with ICF, insulated concrete forms. It's a great system, and if money is no object, it's probably one of the best system that you can build a house with. It usually costs quite a bit more than what the salespeople tells you they do, but it is a great system. Again, you really, usually you need to use contractors that are specialized in this. Even though some of these manufacturers says that anybody can do it, that's just like anything else. Sometimes good products with bad installations make a bad decision. So the double stop walls is fairly common in the Northeast. We don't see that much down here in the South. I don't know much about it other than what I read in websites and books and so forth. But it is a good system as long as you build it correctly. So there are different options that you have for walls, for floors, for ceilings, for roofs, for all that. So as long as you do it right, as long as you plan ahead, the moisture management, the permeability, I know that many of us cannot afford to use WUFI analysis on every project, but ASHRAE Fundamentals is something that is available to anybody and it is free. So why don't you really pay attention what type of systems you're using on a house, especially on custom homes, make sure that you're using the right product for the right application and the right installation instruction. So heel framing. The codes are now jumping quite a bit. In climate zone 0, which it's probably in the Caribbean or somewhere, and South Florida is climate zone 1, they stayed at R30 in the ceiling. Climate zones 2 and 3 have jumped to from R38 is now R49. Climate zones 4, 5, 6, 7, and 8 are R60. So if you think about it, even in climate zones 2 and 3, with R49, which most of you are on right now in the north, R49 is basically about 14 inches of insulation. And you cannot do that with just framing material, with just stick framing material. So at some point, you need to have heel framing on the edges. Even if you're trying to do a continuous insulation, where if you're in R49, continuous insulation will bring you to R38, or if you're R60, continuous insulation is R49, you still are going to have to use heel framing. I believe the code needs to address this on the roof framing, that pretty much every single roof that we do today, you need to have a heel framing. This is what I was talking about. So it's pretty important to know now that, especially starting in climate zones 4 and higher, think about this. Just for condensation value, okay, the impermeable insulation that we need to use starts at minimum 3 inches, and every climate zone it goes up another inch. So if you're in climate zone 6, you're looking at 5 inches of rigid foam on top of the roof decking, or closed cell foam sprayed under the roof decking if you're using a conditioned attic type of assembly. So I'm always thinking, what is the labor pool that I have to make a decision of what type of attic or roof assembly I'm going to use? If I have a labor pool that is educated and can follow instructions, I don't mind putting 6 inches of rigid foam on top of the roof decking if I know that they're going to be conscious enough about that installation. But if I know that here in the South, we get a lot of turnover on framers that 99% of the time are not going to read the details that you put on the plans. And so when that happens, you need to start thinking, what is the easier way to install a roof decking? Whether am I going to use rigid foam on top of the roof decking, or is it easier to install spray foam underneath closed cell and then open cell? The other thing is the codes address that you can use the performance code to reduce the amount of insulation you put in the roof assemblies. Here's the thing that I just make you think about is the laws of physics and chemistry do not care what type of building permit you pull your house under. It doesn't care whether you're in the performance code, or it doesn't care whether you're in the comparative code. It doesn't care whether you are in the prescriptive code. The bottom line is the laws of physics test, it says that if you put R20 insulation against the roof deck in climate zones 2 to 8, eventually the possibility of having condensation on that roof deck, it goes exponentially high. And if you don't know that about, there's David Wickley had there's plenty of information on the web. They had over 400 homes in Houston having problems with condensations in the roof decking. The same thing happened in Chicago. So if you think that only can happen in cold climates, think again. Always try to use, or at least I do, I always try to do, when it comes to insulation, I always do prescriptive. I don't care whether we're doing a performance code house or whatever it is. The prescriptive, it's always applied to insulation. Why? Because I want to protect my clients for future problems with condensation issues. I highly recommend that you do that. This is basically one of the ways the code. If you look at R806.5, it tells you that for condensation in an attic, you only have 3 ways. You put all the insulation on top, all closed cell, rigid foam on top. You can also put some of it on top, rigid foam, but then some permeable insulation underneath. Or you can put both the closed cell underneath and then permeable insulation below that. Now, in the 18 code, the vapor diffusion port was allowed in the code, but it is only allowed in climate zones 1, 2, and 3. And I know I read in the Fine Home Building magazine and Green Building Advisor that people are doing that in climate zones 4, 5, and 6. You're doing it at your own risk, but it is a good option. We started using it down here, but you also need to make sure that the subcontractors that we work with are people that know how to follow the code and know how to follow installation instructions. Okay. Here are some of the things that we know that in the 2018 code, there were 3 air exchanges of building, 3 air exchanges at 50 pascals for most of the country. That since has been downgraded to 5 air exchanges of 50 pascals in the 2021 code. Having said that, one of the requirements I have on all my projects is 1 air exchange of 50 pascal. That is maximum. And so doing the right things always will give you better protection for your clients. And one of the things that we do is make sure that we seal the plates. We don't use the little thin seal sealer at the bottom. We use really good seal sealers. We use tapes on the outside. We put details on the drawings for those things to be addressed. Unfortunately, very little happens in the field. And we know now that in the 2021 code, it is required to have 5 air exchanges at 50 pascals, but just doing the right thing, you can get to 3 or below. And like I said, in our case, we normally are below 1 air exchange at 50 pascals. But this is what it is required for the zero energy. If you're in climate zones 1 and 2, you need to be for single family detached is 2 3/4, 2.75. If you're in climate zones 3 and 4, it's 2.25. If you're in climate zones 4C and 5 and through 7, now you're at 2. If you're in climate zone 8, you're 1.5. So now is telling you you need to improve the building envelope tightness of the houses that you build. Again, not only the seal plate, but also there's a lot of air leakage that happens on the top plates of the house. So we need to address that. And there is minimum requirements for each climate zone also that we need to address. Here are some of the typical systems that we use. I happen to like, very thick sealers. There are 3 or 4 different brands out there that you can use. Protector Wrap happens to be the one that we use the most. Is a company out of Denver, Colorado, and they do a great job offering different types of seal sealer that really do seal the envelope correctly. But you can also use caulkings, and there's different ways to do it. But obviously, people are using a lot of air barrier anymore. But you also need to know that you need to make sure that for an air barrier to work, the holes need to be fairly small. And so no big holes are allowed for that system. So I have a small blower door test that kind of graphically explains that for a typical 2,500 square foot house, the area that basically is open for air leakage at air exchanges at 50 pascal, we're looking at for less than 1 air exchange at 50 pascals, it's about 3.5 inches square. For one is 1 air exchange at 50 pascals is 4 inches a square, and so forth. For a 3, which is the old code, I guess, not the 21 code, but for Energy Star and also for Zero Energy Program, you're thinking that you need to have somewhere around between 7 and 8 inches a square of a hole. And so that is pretty tight. That means that we need to start paying attention how we seal our house on all the critical joints that we have between different materials.
Armando, before we get into Windows, can you help us get through a couple questions, if that's all right?
Sure.
Since we're at our halfway point. Yeah, so we're going to be going on for another hour for this session. This is a 2-hour session, everyone. So I hope you'll stick around. And if not, you can go to our YouTube channel and grab the recording when it's out, and we'll get you access to the continuing ed quiz. So yeah, there's quite a bit of questions. Let's just see if we can get to some, and let me know, Armando, if you're planning to get to them later. We'll just we'll just let me know and we'll circle back to them. No hard feelings. So one of the questions was, well, it sounds like you're probably going to get into mechanicals in a little bit, right?
Yes,
Okay.
so far I've only got building envelope.
Okay, and then a little more on solar ready, I assume, right, too?
Correct.
Yeah, so I'll hold some of those to a little bit later here. One of the questions was in regards to it was kind of in regards to the double wall assembly, and someone was mentioning that a structurally insulated framing system or insulated stud may be comparable to a double wall system. So I guess this is really a question for you. Have you seen these systems before, or used them, or have any genuine thoughts on those?
I have zero idea, and I have never designed a house with a double store systems.
Okay.
I have never used a system like T-Studs. I mean,
Right.
all
Sure.
I know is what I read, in the blogs and people that use it. I know in New England, the double stud wall is pretty popular, Also, you have people using trusses on the outside, like oh, I forgot what it's called, but there's one that you build a regular wall and then you add trusses to the outside, just to put more insulation in it. But all I know is what I read, and really I don't know much about that.
Sure, fair enough.
It's not what we use down here.
Right. Some questions here about, have you looked at achieving any of these results while not using any kind of foam, whether it be spray foam or rigid at all? Have you attempted that, or if for clients who might be concerned about foam for whatever reason?
We're doing actually a house right now. It's we're talking 11,000 square feet heated, 15 total, but the children, this folks, they got a couple of kids and they have respiratory issues, and they didn't want to foam on the inside of the house. They don't have a problem on the outside of the house.
Mm-hmm.
Okay, so I happen to like dense packed cellulose, and I use it pretty much on all houses. Now we're also using rigid foam on the outside, but they don't have a problem with that, being that it's on the outside. All the attics of the house are conditioned space, and so we're using I-joist, 14-inch I-joist, and we're dense packed those I-joists with R49 insulation. That is climate zone 2, or at least Dallas County, in the 2021 code, they included Dallas County and Tarrant County, which is Dallas and Fort Worth. They moved them from climate zone 3 to climate zone 2, except that I still treat it as climate zone 3 because, as we know, a year and a half ago, the whole town froze up. So, I tried to be practical and do better than code. So, anyways, the only situation we're using foam on this house is on the rim joist, and we're using a water-based open cell foam, on the rim joist. And the reason for that is it is really hardly impossible to insulate a rim joist correctly. We're using open web trusses, and so that's what we're doing.
Mm-hmm. And then, speaking of rigid foam, 2 questions. I'm going to try to combine them into one here, if that works out. First is, how can you attach shingles to rigid foam? And then second is, per rigid insulation on the top of the roof deck, is it recommended that the ice water shield be installed on the roof deck before the insulation? And what's the pro and con of doing this for the impact on moisture drive and drying?
The insulators that we use, they like to put the peel and stick water resistant barriers on top of the roof decking. And the reason for that is when we put rigid foam down here, typically I like to use polyiso. I know that in the south, polyiso retains the R value. In the north, it kind of reduces from 6.7 to about 5 or less. But anyways, down here we use polyiso. We tape it, so that also becomes a moisture barrier. If we're using tile roof or we're using metal roof, then we'll put battens, and so we'll have a ventilated roof decking. We put 1.5 inch, even though we're required to do 1 inch, we put 1.5 inch because it matches the perimeter 2x4 on the roof. If, like, for example, I'm designing a house in Ann Arbor, Michigan now, and climate zone 5, we're required to use minimum R25. So the question now is, we haven't got this far yet. Do I want to put 5 inches of rigid foam out there? I want to know who the builder is, okay? And if not, are we going to do a ventilated attic, okay? As far as how to do it when it's shingles, you have to actually you have to put a nailing base, so you have to put a second layer of sheathing up there, but you only are required, I think, is 3/8. There is a product that is called Hunter Panel, and if you got the budget for it, it's a great product, and it's basically already built a sheathing with a foam with the air space with the second layer of OSB. It's a great product, but it's not cheap.
Right. And final question, you kind of started alluding to it, but it sounds like in some cases you vent attics and maybe in other cases you don't. Is that true? It just kind of depends.
Yeah, it just depends. Sometimes it's what the homeowner wants. Sometimes, like for example, this big house we're doing, sections of the attic are going to be used for storage. Other sections are going to be used for a gym. Some other sections are going to be for their son's boy cave. Some other sections are going to be used for mechanicals. And one of the reasons that I like conditioned attics for mechanicals, especially, think about down here in the South or in Texas, New Mexico, we don't do basements. So while you have that cost up north of doing a basement, for us, the cost is doing a conditioned attic, okay? And so having a conditioned attic for mechanicals, it's a great idea. But I also do ventilated attics, and we're doing houses where we fur down if this was a 4-hour presentation, I would show you a lot of details, okay? And so on single-story houses with no basements, we put all the mechanicals in a closet. We fur down the hallways. So we do 10 or 12-foot ceilings. We fur down the hallways. And we run trunk and branch for the mechanical system. So there are ways to do things if you want to do it right, But as far as the attic being conditioned or unconditioned, it's neither here or there. It's whatever the homeowner wants, whatever the builder wants, and I'm very adaptable.
Yeah. Yeah. And one of our members mentioned that we should have you back on someday just to talk about your ideas to building beyond zero. So it sounds like maybe we'll have you back for that at some point too. So
Well, as I told you, I can do this presentation for 2 hours or 2 days.
Yeah. So we'll talk about that. But and before we move on to Windows, just a quick, someone had asked about Passive House. So to be sure, everyone, the international version of Passive House, to my knowledge, doesn't reference any of this stuff. Doesn't reference Zero Energy Ready, HERS Index, all those things. Certainly a good idea. PS, on the other hand, Passive House Institute US, this is another one of those baseline building things, right, up the scale as we go. And so Passive House US requires all of this. So this will actually go into our Passive House playlist as one of the components. So just to be clear on that for everybody, for the question that came in. So yeah, why don't we, on that note, why don't we talk about Windows, right? That's always the biggest barrier to Passive House. So good segue.
Thank you. So again, Windows, as I said before, they become more sophisticated. Obviously, there's minimum requirements per climate zone. I'm one of those designers that believe that most houses, I'll use 99% of the houses I design, I'll use windows that the manufacturer just builds every day. I don't try to make custom design windows just because if a manufacturer produces 200 types of window, why? I mean, if I can design a house with their windows, I need to get a different job, I guess. But the one thing that also it plays into the decision of the windows that we use, as you will know, coming out of COVID, a lot of the windows that we use are high end, and they're taking 8 months to get them. And so it's not like, you really need to plan ahead what you're going to use. And so when we do that, it's a lot easier if you order just one set of windows for the whole house. Same U value, same solar heat gain coefficient, same for the whole house. Try to pick and choose solar heat gain coefficients for the north side or the east side or the west side or the south side or all that. It just creates a nightmare, not only for the manufacturer, but also for the retailer. And to me, keep it simple is stupid. I think that's part of the my thinking when I design when I use windows. And so I also like flanged windows. Why? A continuous flange, because again, as I was talking about labor pool, it's a lot easier to install a continuous flange windows that, as far as moisture management, than it is to do a flangeless windows, or those windows that come with a corner cut out so they can ship them, with the flange folded. Those little plastic foamy thingies that they put on the corners, half of the time get lost, the other half gets in the mud. And so I just prefer to have, flange windows because I can trust installation. Not all windows that are installed on the houses that I design are installed by manufacturers, which I do like that because they do that every day and twice on Sundays. And so they have a better way to install a window than just a typical framer. So that's just a personal opinion, but I know that been doing high performance houses for 20 years, and it just seems like you find a system that works, you stick with it. So water management is probably the number one thing that we all need to address on a house, making sure that you design your roof assembly and your wall assembly with the correct products, the correct installation, the correct methods. As I said before, a good product with a bad application or a bad installation, it just creates problems. So you need to start out by making sure the house is dried up on ground. And if you do crawl spaces or basements, obviously there are ways to do it right. And it's making sure long time ago in my previous life, I was building in houses in the Midwest, and every house I've ever built had basements, and so we designed houses with interior and exterior drain going to a sump pumps, drain pipes going to a sump pump. So those are things that, I mean, you must do. And a lot of times I see details with no drainage whatsoever on a basement or a crawl space. And you know, so those are things that need to be make sure that we follow through. Same thing, how we do flashings, whether it is on a roof or on a fireplace chimney or two planes coming together, so forth. And there's plenty of materials to do rain screens, as I was saying before. You can use home slicker or slicker max if you're going to do a stucco. You can use 1x4s, and I see a lot of times questions about whether this 1x4 rain screens need to be done with treated lumber, and it does not. Just because if one 1x4 gets wet, obviously being that is vented, is, you know, it'll dry itself out. Another thing is you need to make sure that you install insect screens on all the openings, and whether you can buy a 36-inch rolls and cut it in 12-inch sections, or if you use products that are already manufactured. They're not cheap, but they're great products to use. Like Coravent is one of those beautiful products. Other things that we use, we're starting to use more and more, is spray-on water-resistant barriers. So those are things that you need to start designing up front with the builder. What system you're going to use, what's more available in your climate, what type of subcontractors you can use in your area. So duct system, it is required now that you need to have a design. Well, the code requires to design manual D, S, and J. So the thing is that when you take that to a building code, I have never seen a building official review that. 9 out of 10 times they don't. I would say half of the time they don't even know what to look for. And so having somebody design the system correctly, I happen to have my own, I can do my own design of the system, but because I'm not a mechanical engineer, I'm not going to put myself in liability for that. But I use that to review every single house I design. I review all 4 manuals. I want to make sure that it was designed correctly. And believe it or not, I had a builder a couple of years ago that sent me a summary, and it had the right address, and that was the only thing in there. Because for a wall section, we had 2x6 cellulose, dense packed cellulose, and 1-inch rigid foam on the outside. What I saw in the summary was 2x4 with batt insulation. From then on, it just had the wrong windows, the wrong amount of windows, the wrong insulation, the wrong everything. I called the builder and I said, do you know this is done wrong? And he said, well, all I care is that I need to present that to the building official to get a building permit. And I said, yeah, but if he sees my details and my specifications and he doesn't match, he may not. He said, nah, no problem. Well, guess what? He did get the building permit. So that tells me the building official never looked at it. So I happen to look at that stuff. I happen to design the chases on the floor trusses to make sure that I can use the trunk and branch. There's no beams, there's no nothing blocking the system. But unfortunately, a lot of what we see is this, okay? And I just call in a bunch of ductopus, okay? I happen to like trunk and branch. It's a simple way to do it. If you can use the trunk in metal, and the branches, the supply branch, you can go up to 10 or 12 feet with a stretched out flex duct. That's the best way to go. By the time you turn to the boot, you need to use a metal turn, so there's not a kink or blocking the airflow. And as I said on a picture earlier before, you need to make sure that you do airflow testing to make sure that whatever you got in the manual J for that particular room, that's what you're getting in reality in there. And we happen to do that on all our houses. So you got 3 commissionings. One when the roofing is installed, one when it's finished, and one you go about 6 months later. And then, because sometimes homeowners, hey, they'll put a piece of furniture, if I typically like to have all the supplies up high, or coming from the ceiling or high on the wall. But now and then, you get one that is designed where the supplies in the floor, and sure enough, somebody will put a piece of furniture on top of that. So you need to make sure that you do some commissioning, after your clients moved in. So there are different types. As I mentioned, ducts and drop ceiling. We use that a lot here, or I use that a lot. Modified attic trusses. I've tried it 2 or 3 times here in the South. In like in New Mexico and Arizona, people are more familiar with it, and they're pretty good doing it. Down here in Texas, it becomes a nightmare to get it done right. So sometimes that's when we do conditioned attics, unvented attics. Sometimes we do, especially on high-end houses. It looks like down here, sealed crawl space is the way to go. If you also have a basement, it's a great place to put all your mechanical equipment there. Design the floor trusses with chases, so you can use a trunk and branch. It's a really good system. Okay, so there are different ways. Here is the ones that you fur down. The ceilings, like I said, typically I do 10-foot or 12-foot ceilings, and so we can fur down anywhere from 15 to 24 inches. Here are some pictures, or it's a picture of an actual fur down ceiling with a metal trunk and supplies on both sides. This is a crawl space, the bottom right, it's a crawl space I designed with the metal trunk going right down the middle and supplying the house. 37 or 3,800 square foot house, and we use one system, 3-ton system. The owner of this house is a mechanical engineer, or he's retired, but mechanical engineer, commercial, and he had 9 tons of air conditioning planned for this house. I reduced it to 3, and he didn't think I could do it right. Proved him wrong, so he's happy on his house with 3 tons. Same thing, conditioning attics. It's just a really great way to do it, and put all your equipment up there. It's what is called the southern basement. Conditioned crawl space. There are exceptions for a crawl space. So if you're in a 100-year flown, or if you're in a marine climate, dry climate, raised pier foundations with no walls, like New Orleans, for example, is a or coastal areas, sealed with capillary breaks and dehumidification. So there are some exceptions, but other than that, you need to condition the crawl space. Great system, though. Again, you can use ducts in the vented area, but they need to be encapsulated, and it's only amount to a small length. You can't just do the whole system like that. Indoor air quality. I'm sorry, I just looked at the time, and I'm just going to move quite a bit faster. So Indoor Air Plus, it's now mandatory with the program, and it's about making sure that our houses have good ventilation. We provide pest barriers. We control our moisture. We make sure that we select the right materials with the right application. We need to provide with radon, passive or active radon solutions, and depending on where we live, sometimes you could be in one of those counties that it looks red, but in that area where you're building a house is not. Or maybe I've done houses down here in Texas where it looks like we're in zone 3, but in that particular place where the house is, we need to do radon mediation. So it's a simple way to do it. Passive weight, you can put a stack tied to the drain tile of the house, and if you're in zone 1, maybe you need to put in the attic, put a electric fan that helps suck the radon out of the house. You also need to make sure that you screen all the openings, from pests. You need to use low emission products, and there's different certifications for homes, for products used in homes. I have not used and I have not designed an open flame house in the last 20 years. And I do a lot of multi-million-dollar houses. So the idea that big houses, they don't want a direct vent fireplace. Now, some of the ones that my clients choose, they're not cheap, and they're pretty fancy, but we're using all direct vent fireplaces or electric fireplaces in the inside of the house. On the outside, we can use regular masonry or isokern or some other product like that. Now, you're also allowed to put gasketed doors and so forth, but I just personally, it's a red line for me to have an open flame fireplace. Obviously, now you're required to use smoke detectors and CO detectors if you have open flames. That's the beauty of electric house. In some areas, especially in multifamily, you're not allowed to have smoking on the inside of that. Need to be aware of what people store in the garage. I happen to design all my garages with a fan that is hooked up to the garage door opener. So every time the garage door opener goes up or down, it runs the fan, and it removes any kind of chemicals or smells from the car when it comes in or whatever. And you can set it for 20 or 30 minutes after it's turned on, it goes off. So It's a good thing to do. Make sure that you have, of course, gasketed doors and seal that house completely. I've seen some guys of high-end homes completely sheathe the house separate from the garage. So they add the garage after they sheathe that wall. So it's a great idea. I don't think it costs that much money, but they make sure that it's well done. So the same thing, no air handler in the garage. It is required now to be in the conditioned space for the Zero Energy program. Not using any building the building structure for as a trunk, and it was used in the past, and not anymore. The program requires up to minimum MERV 8, but I think pretty much most people, especially now after COVID, are using MERV 11 and MERV 13s. We happen to be using quite a bit of 16s. You need to plan for that because that creates more static pressure in the HVAC system. Some of the ERVs and HRVs, they don't have a way to add a high MERV filter, but that's all you can do. But as far as the HVAC system, I highly recommend that you plan for a MERV 13 minimum, and hopefully MERV 16. But you need to plan for it. You need to make sure that that's part of the equation when you design the system. Again, ERVs or HRVs. If it's a small house, we use spot ERVs. They're just easy to install, minimal ducting that needs to be done. You put them on the ceiling and just let it go. If it is big houses, in some cases we use 2, sometimes we use 3 or 4. So it's really a good way to have continuous ventilation on a house.
Armando, are ERVs actually required, or is even balanced ventilation required on Zero Energy Ready?
It is not requirement, it's not mandatory, but to me, it's the only way to ventilate a house. I know that the code allows exhaust ventilation and supply only. The problem with exhaust is that you put negative pressure on the house. Yeah. And so when you put negative pressure on the house, any type of bad stuff from the outside, or the soils or the cars or the chemicals or whatever, comes into the house. When you have supply, the problem with supply is that when you're in the shoulder season, and if the system is not working, you're not getting mechanical or ventilation in the house. If you are in a very humid area, then you got problems now because you are bringing humidity. If you're in 100-degree weather, you're bringing hot air. If you're in 0-degree weather, you're bringing cold air. So all those issues are happening with supply only. So to me, having a separate independent ERV or HRV, I don't use HRVs, but using ERVs as an independent system is the way to go. And as I tag along there, I use also dehumidification, okay? And to me, this is critical anymore. Again, for areas where there's high humidity, I know the program wants relative humidity less than 60. I actually put on my specs to be set at 50 or less. It's a better way to go, but the program only requires for 60. The good thing about it is that now pretty much every system that you can buy now, it comes with an app. that you can control the system. That is good and that is bad. The good thing is that you can control it. The bad thing is that people that don't know what they're doing. And if you have a system that is not designed and installed correctly, you're making it worse. So also, there's all kinds of indoor air quality smart devices that you can add to your house. Brown, Swidget, Neutron. I mean, all these companies are coming out now with indoor air quality sensors, that they'll check the moisture, they check the temperature, they'll check the indoor air quality, pollutants, all kinds of stuff. So those are things that we're starting installing in a lot of our houses, and they don't have to be that expensive. Some of them are very reasonably priced. Okay.
Yeah, and it's interesting. I was just pulling open the new version of Indoor Air Plus and surprised to see that balanced ventilation ERV still not required, even under the new version, at least for now. So people can still get their comments out there. However, ASHRAE 62.2 2019 is required. That's a lot of air needing to be moved. So trying to move that with just a bath fan or a supply only probably is going to be a lot. So
well, and you need to think is whether you're using 62 to 2013 or whether you're using 2016 or whether you're using 2010.
Right.
So
and they're referencing 19 in this new standard, which I suspect 16 is pretty, I know almost doubles 10. So.
Correct. And then you got the same guys at ASHRAE like Joe Stebrick and I don't know, and Alison Bailey, and they're all arguing, how much ventilation is the right ventilation, So at the end of the day, you just kind of have to figure out what you think is best for your client,
Yeah.
So,
thanks.
Well, hot water is also a big deal. We spend about anywhere from 15 to 20% of our energy use in hot water. And so one of the things that this program now requires is that it needs to be, if it's builder installed, it needs to be certified Energy Star appliances. Again, we're gonna be doing 100% low efficacy on the lighting. Electric fans, they need to be Energy Star. Water sense, of course, it's a big thing. Gary Klein in California came up with a study quite a while ago saying that we use 90% of our hot water in 1 hour in the morning. So where we're heading to, and at least pretty much all the houses that I do, is either heat pump water heaters or electric tanks that have a recirculated on-demand pump. You don't want just a pump circulating hot water all day long every time it cools off, especially if you have a hot heat pump water heater. You want to make sure that you have an on-demand pump. So during the day, that hour that you start using water heater, it'll start running hot water into the system, and then of course, it kind of shuts off during the day when you're not there, not using it. Of course, if you have a small house with all the hot plumbing in a concentrated area, probably using a manifold is the way to go, and so forth. But now, as I said before, you also need to be, if you have gas in the house, you need to be required to have an area for a heat pump addition at some point in the future. And this is what I was talking about, the energy use, that what happens between the houses that we had before and what the high performance houses are now is kind of amazing to see when you look at the manual J's, where your electricity usage is switched to and from, and so now you can manage it a lot better. As I was mentioning, that There's smart panels that also allows you to control whether sections of the house can be shut off completely, or half of the time, and then critical areas like, for example, a refrigerator or a freezer, and air conditioning or a heating, be turned on 24/7. That works really well, especially if you have renewables installed on your house, because it gives you a really good way to manage your electricity, especially on emergency, especially if you have batteries, or even a generator. So water sinks, as you well know, people are becoming more familiar with all the options that are now for low flow toilets and faucets and shower heads and so forth. But now it's required. So based on water sense, you have different options of how to get there to do a good hot water system. As I said, if you can control or you can design all your terminals for hot water in a very short space, manifold is a really good system, a really good way to go. If you're in an area on a small house that all you need is just one or two lines, it's also a good way to go. Like I said, for me, it's difficult because for most of the houses, they're pretty far out. They're 5,000-10,000 square feet. So they just, we spread them out quite a bit, but using a recirculating pump. But like I said, I don't think it should be on a timer. I think, just a recirculating pump, you can use a timer or you can use a on demand. And I happen to like on demand a lot. So heat pump water heaters is just like air conditioning heat pump. It uses the same thing. It uses the air from the outside. It does not work as well in cold climates. So unless you happen to have the heat pump on the inside, so make sure that how it is designed. And like I said, there's a lot of people saying that they don't work as well with recirculating pumps unless you put on demand on those water heaters. So I'm make sure that you do the research ahead, because again, you may end up clients with cold showers. Okay. So it just takes a longer time for the water to heat up on this heat pump water heaters. So same thing, like I said, air conditioning systems, heating systems. Now there are combinations of heat pumps that not only heat for space conditioning, but also for water heaters. So that may be an option for some folks. Again, there's also another options, and as long as you have a higher efficiency water heaters, also regular electric water heaters, they need to be WaterSense labeled. Also, make sure that you have shower heads, faucets, everything else. You can also store water. There's a water distribution systems now that they all need to be very well insulated, and I guess using a trunk and branch, kind of the same thinking, the same theory of what you do trunk and branch on the HVAC system. Think of using trunk and branch on a hot water distribution system. So there's WaterSense in their website. They have a tool that helps you design the systems that you put on a house, and it can tell you whether it works or not, or whether it will be accepted by the WaterSense verification process or not. So you need to go there. Solar ready. The cost of solar ready is going down. So today, a lot of the houses that I design are so efficient without solar that the homeowners are not installing solar. I think probably about a fourth, 1 out of 4 houses that I design install the solar panels or solar roof. We're doing right now, I'm doing my first Tesla solar roof system. There's quite a learning curve in there. You got to use. They do all the design. They'll do everything. I'm like I told them, I'm going in there like naked, knowing nothing. They just they design it. The price keeps going up as I don't know. I guess as the weather goes up or down, the price goes up and down. It's very makes me nervous. But anyways, the homeowners are happy. They like it. And we're putting a 36 kilowatt system with 5 batteries and also a generator. So one thing I learned is Tesla batteries, they do not get recharged with generators. I think they're working on that because that's a downside for them. One of the things that it changed with version 2, Zero Energy Star version 2, is that the whole United States now it's required with few exceptions. So if you already have PV on site, if you're connected to a community solar, if your location has significant natural shading, so like if you live in a forest or something like that, and depending how the house is oriented and so forth. Now, remember that there is already federal legislation that no homeowners association, no municipality can block you from having solar. They can, or not installing solar. They can tell you whether you can put it, but at the end of the day, there's been a couple of court cases. One of them, I think, is in North Carolina, where the homeowners ended up putting solar panels on the front of the house. They were taken to court, and they actually won it. They said that was the only place that they could get good solar supply. So that now that the whole country is now available for installing solar panels. You need to think about what system you're going to use. As I said, if you're using solar panels, it's one way to do your system. If you're doing solar tiles, that also whether it is what system of tiles you're using. Like I said, my first one is now with Tesla, and it's fairly complicated. They have their own system, whether you're using batteries or not, whether you're using a generator or not, whether that generator can supply direct to the house or can charge the batteries. It's another system. So those things need to be thought out up front. You need to have an area in the house or outside where you install this. Okay. All the systems are ready to be installed outside or inside. Most of the time we install them inside the garage. You need to make sure that you have the garage wider than where the cars are going. If you install it on the back wall of the garage where a car can hit it, municipalities are asking that you need to put bollards in there so somebody doesn't by accident smash into the system. So I tend to design the garage wider, so we put the systems on the side of the house. So those are things that you need to start thinking about. As I said in the beginning, if the homeowner says, I'm going to install a system, or I want, having a zero energy ready house, plan ahead, because eventually they're going to put that either on inside the garage, or if you put it on the outside, or in an additional building, you need to address those issues. The economics for homeowners or for builders and homeowners who think that this houses cost an arm and a leg, and they do not. The Rocky Mountain Institute in 2019, they came out with a study. They looked at the top 50 markets in the United States at the time, and they figured that it costs somewhere around 1.5%. Now, this is the average size house. Most of the custom house I do, they blow this to the kingdom come, just because the amount of materials, high-end materials that they choose. But the typical house is less than 3%, okay? And one of the things that you can download, you can go to the Rocky Mountain Institute, download this document, and you can see that in different markets. Now, here they got a graphic of 4 markets, and the cost of the dark blue is for zero energy ready homes. Zero energy homes, the ones that have panels or renewables installed. The light blue is for zero energy ready homes. Actually, I got it backwards. Zero energy is the light blue, and zero energy ready is the dark blue. Here in Texas is somewhere around 1%. I got a couple of builders that I've been working with them for quite a while, and they build it for the same cost. And so it doesn't cost that much more. What really adds to especially in the custom homes, is the selection of, materials, flooring, cabinetry, instead of, paying $100 a square for shingles, that their roof may be $1,500 a square, so that's the difference. So the steps that you as a builder need to take to become a partner is go to the website. It is free to sign up, become a partner. You need to have a introduction webinar that they have it online, or I happen to provide those webinars too. Follow the program specifications. Some of the advantages that you have is that there's a lot of education already there. There's the Tour of Zero, which is homes that have been designed around the country by production builders and custom builders all together. You can go in there and select in your area who's building those, and click into those houses. It has documented information of those houses. So there's all kinds of things that are available to you. Marketing toolkits, already pamphlets and websites, everything that it is designed already for you. So once you have the registration, again, you sign the agreements, you look at the guidelines, you can make the commitment whether you're 100% zero energy homes or whether you're only doing certain things. And I'll give you this advice that I give to all my builders. It is really hard for any builder to have more than one system to build a house. It is very difficult, because that confuses the person who's designing the house. It confuses the subs. What are we doing on these houses? But on these houses, we're doing a different system. So if you're going to do this, I highly suggest that just go go all the way 100% in and start doing it in your houses. You may want to start out with just one house to try it out, but you're going to find out that this is not that hard. This is just more like paying attention and thinking of solving problems before they become problems. Okay. So as I said, you need to take a training. You need to be registered, certified, and you need to build at least a home a year. I don't know whether how is that enforced or not, because I got builders that only build one home every 2 years, and so there's just big houses, and so they take that long to build, and so. But anyways, go on the website and look at the guidelines of what you need to do and the process that you need to do. The same thing, there's raters can become partners, architects, designers can become partners. So go on the program and find out what you need to do to get certified to do these projects. And that is basically the same people that you use for Energy Star. You can use it for Zero Energy as far as inspections and doing the verifications. There is already marketing material that you can use. You can use their logos. You can use their brochures, and their brochures are kind of cool because there's an area that you can put your logo in there, and that's it. Send it to Kinko's, or I guess it's FedEx now, but and have them make the brochures. It's just that simple, that easy. Same thing that you can do for different marketing materials that they have there. Just the message is already done. Like I said, there's videos that you can incorporate in your websites, or in your material. That, like my emails, they all have at the bottom in there a video link for Zero Energy homes. Again, here's pictures of this right here is a video of Zero Energy program for people to understand the advantages. Or so. This is in the tour of homes that happens to be a home certified. Is telling you how big it is, the HERS score, and the amount of money that their energy bills. But usually there are several pages with information about each one of the houses. You get to use their logo. You get to use marketing material. Like I said, this is a space where you can put your own website. Your own logos and information. Here's the tour of Zero. This is where you can go on the website and just click in the area where you live. And you get to see who's in there. Down here at the bottom, where you look by the state or near where you're at and see who's in there. Click in there and click on that project, and you get to read about that particular project. They have a little floor plan of the house, so you get an idea and general information of the house. And people go there. Right now, I'm doing 2 houses in south of Houston because folks found me on the DOE website. So, hey, that's free advertisement. So I didn't pay for anything. Once a year, they do the EPA conference, and in there they give prizes to the folks that have won awards for different projects, zero energy houses in the country. And a couple of my builders have received best houses of the year in this award. So also they have. If you've never been at the Building America Solution Center, you're missing out a lot. There's a lot of information in there about how to do things right. And so it's free. It's right there on the on a website that you can take to the job site. And if you have a sub that is trying to figure out, okay, where do I need to put this caulking, or where do I need to, how do I need to seal this wall or whatever, right there, there's all kinds of details and information on how to do things correctly. So buyers are getting smarter. A lot of my clients, I got clients. I was talking to Brad a little while ago, that I have clients that are doctors. They know more building science than the builders, and so they know what a Hursa score is. They know that if a typical house uses so many kilowatt hours, just by doing the right thing, they are educating, and that energy efficiency in the long run, it pays off. Typically, a zero energy ready home, you can return on investment in less than 3 years, or at least that's my case with my clients. And so folks know about this stuff, and they know that the house is a system now. You can't just pick and choose, well, we're going to do this, we're going to do that. I always tell my clients, if you can afford what you think you can afford right now, let's reduce the square footage by 10%. And in that way, you can afford to pay what, a full house the way it should be done. So the other thing is there's bragging rights. Everybody knows there's a lot of programs out there in the country right now. I happen to believe that Zero Energy Ready Home is a great program. It is known that houses that have the systems, they're getting appraisers that are somewhere in the 10% higher than other appraisers. So just not following these guidelines, you're leaving money on the table. That's my opinion. So this is a typical house that I do. Every single house that I design is zero energy ready guidelines. Every one of the house is also follows the guidelines of universal design. They're all follow the guidelines of the healthy house. They also follow guidelines of fortified home, depending on what area you're in. All the houses, they need to, there's a goal in the very front of the front page of the plans. It's a big thing that says we're going to try for one air exchange at 50 pascals. It's right there on the front page. It's also right there on the front page. It says we're going to try for a low Hurst 40. And this is minimum. We typically do better than this, but this is minimum. We also design down here in Oklahoma, Texas, Louisiana, we're getting more and more tornadoes. You see that happening. We design minimum to EF2 tornadoes. Like the house we're doing in Houston, we're designing for EF4. Typically, we get 1 ton of air conditioning per, I put in there minimum 1,000 to 1,500. We're usually somewhere around the 1,500, 1,200 to 1,500. Again, sometimes because of the equipment that is available, that's what really bother us. So there's a difference between manual J and manual S as far as the system that you can put on a house, but it is done correctly with people that know what they're doing. Obviously, we use minimum ASHRAE 62.2, and we try to get, when we install solar systems, we go for 2 to 2.5 kilowatt per square foot. This happens to be a house that won awards at the DOE Zero Energy Home, 5,000 square foot house, 10 kilowatt system. It has the way the house was designed, we needed to use 5 tons of air conditioning. This house was designed about 7 years ago, and it was people moved in about 5 years ago, I think. But it also has, a lot of extra stuff. Everything in this house is like a modern art museum inside, and it has 2 bars, a theater, a 70-foot pool, a hot spa. And so even with that, their energy bills, their first year, it covered 92% of, and of course, here's a copy of their first bill. You can see up here at the very top in here that has $187. That was before they moved in, and or before they hooked up all the panels and everything. And then just in the first month, they went from 187 to 187. I think their bills were somewhere on, like I said, they covered 92%. Some bills were, $40, and but some were none. So part of the tax credits, the Inflation Reduction Act, was that, as I said in the beginning, that it was also extended to the year 2032. And so you have 30% of tax credits, and is retroactive to the year 22. In 23 and 24, it decreases, but at the end of the day, it's a great tax credit. If you build a house that is super, super tight, like I said, some of my clients, they don't install the equipment. They just think that eventually they will when even goes farther down in price. But so my advice to you guys is design your zero energy homes wisely. You need to figure out everything, or at least as much as you can, before you start designing the house. Make sure that you have details on the drawings, because if you don't have details, chances of doing the right thing, it diminishes a lot. Okay. Work with educated contractors, choose the right systems, the right materials. Not every material is good for the right for certain applications. And if you, on top of that, you don't install it correctly, you're creating problems. Okay. As I said, engage with approved and certified appraisers. The appraisers actually have an addendum. This addendum is, you need to look it up. You need to download it, because you need to give this to your lenders and the appraisers. People that do that, they're getting appraisers that are almost 10% above a regular appraiser. The problem is that the real estate community don't know that, the builders don't know it, the bankers don't know it, the appraisers don't know it. If a homeowner requests that, you must do that. Okay, it is something that mortgage lenders, they know that, or some of the mortgage lenders know that if you request it, they must follow through. So lenders also have energy efficient mortgages. It just blows my mind how much money is left on the table because people don't know the advantages that they have with certain programs. Okay. And work with zero energy savvy sales professionals. If you're gonna do spec homes or multifamilies or production builders, and your salespeople don't know how to sell high performance houses, educate them. Bring people to educate them. There's a lot of free information online right now. There's no excuses. So good luck to you guys. Thank you for inviting me. Thank you for bringing this opportunity to you. And there it is, my website and my email, my contact information, and the email for the program. So I'll be here for questions and that you may have, Brett.
Yeah, thanks, Armando. We've got several questions coming in. Before we get to those questions, just real quick reminder for the LEED accredited professional portion of this course. A reminder that the Zero Energy Ready certification program pre-qualifies, again, as a reminder for the LEED for Homes program under 15 points in the annual energy use, energy and atmosphere section, both for V4, V4.1, and that's multifamily and single family. It also meets a couple of the requirements already within the program and gains an additional bonus points. And as I reminded you, yeah, a lot of these homes are achieving HERS ratings greater than 58. So you might be able to just pick up more points in your annual energy use for LEED anyway. Armando, what kind of HERS ratings are you typically seeing on your projects? I think you talked a little bit about that, but what are you seeing out there?
The ones that the Zero Energy Ready, in other words, it doesn't have the solar panels or tiles. It's somewhere around between 36 and 42 or 43. Mm-hmm. The ones that install solar panels,
right?
It could be 10, it could be minus 10.
Right.
So.
Yeah. So yeah, like you just said, 36 to 43. So, there's quite a bit of leeway here before solar gets added on how many points these types of homes are getting. And also, to be clear, HERS index is one way of looking at it. There's also the energy rating index, ERI, which is really the direction we're headed now, I believe. And so you can use that interchangeably. Now there's more to it than that, but you can effectively use that interchangeably depending on which agencies you're working with to achieve these credits. And then also, again, a reminder, you have to be Indoor Air Plus certified. So Armando talked a lot about those components. They already pre-qualify you for a majority of all the prerequisites in LEED, as well as several of the credits. So like we're saying, somewhere between 23 to 29 of your points are already there for just doing Zero Energy Ready certification. You're taking care of a bulk of that. And then also, it sounds like, I believe, Armando, you mentioned water conservation. You either have to pick WaterSense certified devices or pick the advanced water heating design, correct?
Yep.
Yeah. So water saving devices, that's going to give you even more points in LEED. So you're definitely well on your way. So again, for those of you who want to watch this recording, share it, access it later, you name it, it's going to be on our YouTube channel. Please go up there and grab it over the next couple of days. If you subscribe, you'll get an instant update. Share it on social media. For those of you watching this in the future, not right now, but on demand, you can go to the quiz platform, take your quiz with an 80% passing rate, and receive your certificate. For those of you watching this now right here live with us, search at gutenbergcerts.com. Mark that as safe. You'll receive your certificate as long as you've been here and you're appropriately logged into Zoom. You will get that, so check that over the next couple of days. And as always, we have to say a huge thanks to our board of directors, our volunteers, our nearly 300 members. We need you to help us get there. We're almost there. And our executive director, Jose Reyna, as well as all of our sponsors, especially our top tier sponsors, Mitsubishi Electric, Rheem, April Air. Believe it or not, they also help you achieve Zero Energy Ready certification by speccing their products. You can do that along with many of our other sponsors as well. So we thank them for their support. So Armando, I've got some technical questions, and then let's get into some process questions. This one came quite a long time ago, and you kind of got into it a little bit, but we now know that, from an air source heat pump approach, there is on one side of the equation your traditional mini splits, right? And I think, in fairness, I too find them to be very unappealing to look at. This machine on a wall kind of laughing at you, right? I mean, and then on the other side of the equation, you have your fully ducted air source heat pump systems. I've had one for 2 years. I haven't frozen to death yet, but you never know. I mean, so far so good. And I'm all electric. But and those systems are great, but they're not as efficient. My understanding is now there's these ducted mini splits, and they can be hidden, so you can kind of get the best of both worlds. So what's your opinion on those? Are you looking at using those, or what are your thoughts?
And we have, and I think the houses we're doing in Houston, we're gonna be doing 2 ducted mini splits. They tend to be also high velocity, and with a small duct system. What it makes it nice is that in this house we're gonna fur down the laundry room and a walk-in closet from 10-foot ceilings to 8-foot ceilings, and we're going to put all the equipment there, and then just run the ducts through fur down hallways, and we only have to fur down about 12 inches instead of more than that. And the houses, they're going to have 2 systems. One of the good things about mini splits is that the size of the equipment, it's better than the big heat pumps, the big system heat pumps, and so you can do half tonnage with some of the equipment out there. We're also, because again, they're in Houston, we're putting dehumidification. But I'm also going to be doing that in the house in Michigan. So, I mean, it's just if east of the Rocky Mountains, you got to have dehumidifiers. That's just the bottom line.
And then on the solar ready side of things, and maybe you brought this up, but just to kind of come back to it. Does that require an engineer to sign off in regards to the solar, the roof and the structure being approved to handle solar?
So for solar, you want to have your roof designed for 10 pounds per square foot more, so it's, on the roof design. So typically we use trusses, so that's an easy way to do it because the trusses already come engineered. For for like this big house that we're doing with I-joist, all the roofs, we had to have a structural engineer anyways on the house, so he made sure that what we had was to code.
You say 10, sorry, what was that? 10 panels per what?
Yeah, just 10 pounds heavier on the dead load for the roof.
Oh, okay.
Yeah.
And then,
we typically do 5/8 roof decking. So,
10 pounds on the dead load.
Yeah.
I'm sorry. I thought you said 10 panels. I was like, that's.
I'm sorry. No,
yeah.
10 pounds.
10 pounds. Yeah, I just wanted to clarify. So, okay.
Yeah, correct. And some I would recommend to use 5/8 roof decking, just because you still, depending on the system you're using. Like, for example, the Tesla tiles, they have their own little thingies, and so those tiles are about 36 inches wide, 18 inches deep, and they have their own little things that you set on it, so, but then if you use panels, now you're mounting racks or whatever you're using. So depending on what you use, you need to make sure that you run that. Usually the retailers, they know what system you need to use, and they'll let you know.
Yeah. You had shown a chart earlier, sort of breaking up the costs, kind of going back over time of the solar application. I guess I'm really curious, truly, when you're building a new home, what percentage of the budget really is there nowadays to be solar ready, right? I mean, does it really add that much more? Is it, I've heard all sorts of things from builders telling me, oh, it doesn't add anything more to the cost, to, oh my gosh, the project will lose it, will never get work again. I mean, probably depends on their attitude and their mindset, but what are you seeing out there as far as just the ready application costs, as far as percentage of
So
total
here's
project?
the thing. Unfortunately, you're dealing with salespeople.
Yeah.
Okay.
Yeah.
And there's really good salespeople and there's really bad salespeople. Okay.
Uh-huh.
And so, unfortunately, as a builder, and I don't mean to be rude here, but a long time ago, I learned the expression that you have to learn how to separate the fly shit and the pepper. Okay,
Yeah.
and so there is, I can tell you how many solar installers or retailers say that, for a 4,000 square foot house, you need a 20 kilowatt system. Well,
Right.
hello, what are you talking about? In our case, that now depends. We're here in the South and the Southwest and all that, most of my work. And so we have more solar efficiency than if you have in Michigan or
Right.
Maine or whatever, right?
Yeah.
But having said that, also there's a builder, a production builder in Phoenix
Mhm.
who uses like 1 kilowatt per square foot,
Yeah.
and so they're making it work. So I guess it
Yeah.
depends on how tight your house is,
Right.
what energy loads you have, all this kind of stuff. Like I said, in my case, is about 2.25 kilowatt per square foot. Okay. Having said that,
Yeah.
there are systems and there are systems. For example, I like SunPower. It's
Mhm.
a system that is an American company. They've been here for a long time.
Mhm.
I know that for the panels, they use source materials from the Philippines and from,
Yeah.
Southeast Asia, whatever, but the company's here in the United States. And I hope that if in 10 or 20 years my clients have a problem, they can still go to them. I prefer, there's some South Korean companies like LG, like Panasonic, that you
Yeah.
can rely on. But then
Yeah.
there's a lot of cheap panels
Mhm.
that are coming from Southeast Asia that you don't know who they are. I mean, there's companies that I've never heard of before in my life, okay? And their price may be cheaper. I know that with SunPower, we're paying somewhere about between $3.50 and $4 a panel, depending
Yeah.
what panel you're using,
Yeah.
and that is
Well,
just a system by itself.
yeah. Well, I wanted to get into the solar because there was a question about, but let's remove the solar panels. Let's just take them, throw the solar panels away, no solar panels, right? I'm talking solar ready. How much does
Yeah.
it cost to make a home solar ready? Again, because I'm hearing all sorts of things.
1% in Texas.
There we go. That was the number. That was
Now,
it. Yeah.
but let me put it this way.
Yeah.
There was a slide about the Rocky Mountain Institute
Right. Yeah.
study. Okay, and I think in Atlanta or in Baltimore or something,
Mhm.
it was two and a
Yeah.
half. Okay,
Yeah.
now bear in mind that is a typical 2,500 or 2,000 square foot house. Okay,
Yeah.
we're not talking. I mean, this house we're doing here in Dallas right now, we're
Mhm.
spending $500,000 on the Tesla system.
Right.
Okay.
Right.
So, I mean, you can't just compare custom homes to, small custom or a small production or whatever. But if
Sure.
you go to the tour of Zero, you get an idea of what they have in there. You start listening and reading about all these builders like Thriving Colorado, I forget the guys in Phoenix, and I mean, all these production builders that are doing amazing zero energy projects, okay, and they're somewhere between 1% and 2%. So there's no excuses. I mean, the problem is when people don't know whether it is the builder, the designer, or the installers, or whatever, is when you don't know what's coming up, they usually tend to imagine that it's going to cost a lot more, and then they inflate the numbers just because they don't know.
Sure. Well, and that's that's always the problem, right? Is when people are uncertain, they just jack their prices up. So that can be a lot of things. So I'm curious there's a kind of a question on what happens when you've got situations for the DOE's Energy Ready program, the solar ready aspect, where solar is not feasible. Maybe the home is completely shaded out, or it's blocked by another building, or what ramifications are there for folks like that?
That was a slide that I have in there that was one of the exceptions. Okay. So if you're building in a lot, which is a wooded lot, and you have no chance of getting sun, but maybe 2 hours or 3 hours a day, you're not required to have that, so.
Yeah. So one of our, members, he asked a question. It's a great question. Why don't we just do zero energy certified homes? And I think you've made some points that, of course, they're ready when your clients are ready to pay for the solar when price comes down. So let me throw some thoughts out there. First, we've got the Inflation Reduction Act. It's now codified the 30% tax credit for a very long time.
But it's to the homeowner.
Right. So
it's not to the builder.
Right. Yeah.
That's the difference. Okay. Right. Because the builders get credit up to $5,000 for building a house.
Right.
Appliances have rebates. Okay, so you can actually get about $10,000 per house as a builder, right?
Right.
But when it comes to the solar infrastructure and equipment, it's only to the homeowner.
Right. No, exactly. So it's a benefit to the homeowner, but typically the homeowners, of course, are paying to have the home built. So when you're having conversations with your clients, like, hey, why don't you add the solar now? There are these benefits. Are they mostly coming to you and saying, oh, it still costs too much. Even the tax credit isn't good enough for me to add it? Or have, and I don't know how your clients are financing these things, but are they being presented with utility bills that they have to pay with and without solar to make an informed decision? Like, are they getting that kind of information at all?
So I know, for example, that the the average house that I designed is 5,000 square feet. It's like 5,200 square feet.
Right.
The average bill for those houses is between $135 and $150 a month.
Right.
Now, down here, we have cheaper electricity than you may have in other parts of the country, right? But there's other parts of the country that have even cheaper than Texas.
Right.
And about 2 years ago, when we had that freeze over, that the whole state got freeze over, I had to renew my electricity contract 6 months ago. Well, guess what? It went from 10.5 cents a kilowatt to 15.5 cents kilowatt. So they jumped the rate 50%. I've heard other people, their rates are going up 70%. Okay. So I don't know, depending on where you're at, and you can figure out, a lot of the homeowners, like I said, that I do, they say, Armando, if I got a 5,000 square foot house and I'm only paying $140 a month, I'm happy with that,
Right. The bill's not enough to encourage them to put the solar on, even with the tax credit. Perhaps it's still
that is correct. Yeah. And not only that, but some of these people, as you well know, we're moving from our houses every 7 years, 5 to 7 years. So to some of these people, they say, well, we'll just leave it for the next guy or whatever, so.
Yeah. Well, I thought I'd ask. So thanks for going over that. So Some other questions that came in on the process side. You had mentioned like a builder has to sign up in the program. They have to build a home every year. So we had some architects, designers, zero designer. Can the designer be the one listed? Can they be the one to lead the project, or does it have to actually be the builder that has to
It's
do
the
it?
builder, yes,
Yeah.
yeah. And
Okay.
I don't like it because a lot of my clients, most of them, they don't want to go through the process of registering, and a lot of my clients are, I have to sign NDAs, and so they don't want to make it publicly anything about their house,
Yeah.
or have their floor plans displayed somewhere or anything. So a lot of my houses don't get certified. I would like to, if I can, because that would be more advantageous, or marketing for me. But no, it's only the builder with the zero energy program, and I don't like it. I don't agree with it. But they don't ask my question. They don't
Right.
answer it.
Right. And I mean, but it, for them to go through it, it's, if I understand right, it's just watch this video and attest that you watched it, right? And then
Yeah,
you're in, right? I mean, yeah,
yeah,
so it's not a huge barrier. Like they don't have to go through a big training. They don't have to go
that
through a
is
long training like
correct.
this.
And
Yeah.
and like I said, they don't. It's a free program,
Yeah.
and they give information and marketing materials and all that kind of stuff for free, because it's all
Yeah.
basically it's DOE's taxpayer stuff, right? So that's
Right.
why it's all open to everybody, right?
Yeah.
And so, but I don't think that they want to be as I don't know, pain in the neck
Yeah.
as NHB program or lead program,
Yeah.
So
Yeah. I'm glad you brought up the Energy Star water management checklist and the durability component of the program, because I know that often gets overlooked. So some questions came in about that to you. If do you typically show the swales on your site plans?
correct. And not only that, but yes, we have to provide a drainage plan. Yes.
And how did the spray on WRB's water resistant barriers, that is, make a drainable rain screen gap?
So what it is just we're applying it to the sheathing, whether it is OSB or whether it is it is another thing. I don't let me put it this way. It's kind of spraying a zip system, right? But in this way, it's already installed. They cover the gaps. Is when it is it the zip system, you have to roll it. You have to make sure that the zip panels are clean when you put the tape and roll it, and so the spray on seems like it's a better application. It does cost a little bit more, so we're using it as an air and moisture barrier, but on top of that, we're putting polyiso, that is tape with the approved tape, so it becomes a second water resistant barrier. And if we use sheet siding, so of course we have 1x4 rain screen. If we use brick, you have that 1-inch air space in there. If you use a stucco, then we'll use a product like Benjamin Updike, roll.
Thanks.
Or stucco, yeah.
In regards to your crawl spaces, what is your preferred way for insulating those?
So we're required down here for minimum of 1-inch rigid foam, and I use polyiso. On the rim joist, we use open cell foam. Now, the picture that I have in here, what we did, this house needed to have the crawl space with the trusses inside a brick ledge of the house. So we put rigid foam on that brick ledge too. Okay. So so everything was all rigid foam. But other than that, we'll use open cell foam around the rim.
Yeah. Going back to the 45L tax credit. So again, if anyone doesn't remember, that credit used to be revolved around an energy target, right? And it was a sort of mysterious energy target. I don't know if you've ever had clients get it or not. I know it was tough to get. But now it's DOE Zero Energy Ready or Energy Star certification. But I know one of the drawbacks to it is that the builder has to retain some sort of ownership structure in the house. Are you seeing that as a viable tax credit for the types of projects you do? It seems to be more focused for production building.
So this credit that I have here, I'm assuming that you're seeing it, right?
Yeah.
Yeah. So this is for the builder, and they can claim up to $5,000 for the house, plus whatever and plus whatever it is on this is for DOE Zero Energy, 2,500 for Energy Star for the house, but also they can claim credits for appliances and brand names and all that. There is DesireUSA.org where you can go and check on your state what other rebates and things that you can get. So there's a lot of rebates and things. Now, when it comes to the tax credit for the renewables, let me go down here.
Yeah, the 25, somebody reminded me in a text message this week, it's called 25D. They text me, how do you get 25D? I'm like, what are you talking about? And they're like, Brett, it's the solar tax credit. Oh, okay.
Yeah. So this credit, so you need to really read the rules, okay? It used to be at one time when it first came out that you had several years that you can claim the credit, okay? So if you put a $30,000 system, you get $10,000 back or $9,000 back, and then you would have had 2 or 3 years to do it. I think now it's only, I think it's I read the rules at one time, but you only have a 1 year carry forward. That's it, okay? So you need to really read but I've never had any homeowner say anything about they couldn't get their tax credits or something like that. But that's between you and that's between the homeowner and the IRS. As far as for the builder, I know that if you build to rent, you can claim that. I know if you're in multifamily and some projects like that, you can claim that as a builder. But typically, this is usually applied to homeowners.
Yeah. Well, and I know I've personally got this solar credit, didn't think I qualified for it. So I, tell everybody that, hey, you might not have to be as high of a tax bracket as you think. Mine was carried over for 2 years. I think this is still carryover. I don't think they got rid of that. That's my personal opinion, but I haven't read the new one, so I got the old one. So I just, but everyone should check their tax credit and their consultants and all those things. So
I'm the last person to advise you on tax and and all that kind of stuff.
But you mentioned multifamily, and I'm glad you brought it up because we had a multifamily person coming in here saying, hey, how does this apply to multifamily? And of course, the first comment I always have is, well, what is a multifamily building other than a bunch of single family boxes, right? And it's actually much simpler than a single family home because you just have all these boxes typically multiplied out. So my understanding is that the Zero Energy Ready program is going to make some alternative paths for multifamily. They've already certified multiple multifamily projects. But what would you just say, I know you're not a multifamily designer, but what would you say to multifamily folks who are starting to dip their toe into this? What do they need to know?
I have no idea.
Okay.
I'm sorry. I just don't know anything about multifamily or manufactured homes. I don't because I've never worked on one of these projects, and so I
Yeah.
I apologize to the person who's asking those questions, but that's something that that he may have to go to the program and ask the question there. So
Yeah. Well, and we'll have the DOE on later this year once they release the multifamily program.
correct.
But I'd have to imagine that if they're following the protocols you've said, they're probably most likely overqualified, for some of these things from what we see on how programs translate from the single family world to the multifamily world, the wall assemblies and all those things. So that's just my personal experience with these programs. So, but that's fair. If you don't know, leave it at that. Now, what about on the renovation side? You and I spoke a little bit about that. You can do a gut rehab to Zero Energy Ready, though I believe it requires quite a substantial amount of work, and there's not going to be really any exemptions for renovations, correct?
Every single project that I've ever done that needed to be gut rehab, it costs twice as much as what they think is going to cost.
Right.
And that is one of the reasons why in the big cities, there's a lot of people that are moving in, tearing down houses and building back up something brand new that is, at least here in Dallas, a lot of people that work downtown that is, they'll buy a $500,000 tear down and build a $3 million or $5 million house in it. My clients, the one that we're doing this big house, they bought a $2 million lot or 1.7 or whatever, and to build nice house was there, but they tore it down so they could build their $10 million house. So it's happening in Denver, it's happening in LA, it's happening in all the big cities, Atlanta and whatever. So people are realizing that to do a high performance house on an existing house is almost impossible because you're dealing with foundation issues. You're dealing with moisture management. 50 years ago, they were using plank. If you got brick veneer, you're going to have to tear down the whole brick veneer in order to do it correctly, or tear the inside, whether it is drywall or whether it is plastered, and then do a whole wall system from the inside. And so by the time you start doing all these things, how about the framing members, were they structurally adequate for what you want to do now? So you keep adding and adding and so that's why you start seeing a bunch of tear downs on all the, pretty much everywhere around the country, just because it just costs more money to do a tear down at this level than to do a new house.
Yeah. Well, and for those interested in getting certified and getting programs for renovations, the new IRA funds that have come out have a 25 home C renovation pathway. They're releasing additional funds to low to moderate income folks. And we have our Green Star program, which is specifically built to give people a good, better, best pathway for renovations. So, Zero Energy Ready could be very difficult. And like Armando said, it's just probably cheaper just to build a new home at that point, right? So, but that's case by case. So, check with your rater, check with your project team. So, Armando, I really appreciate you hanging out here a little bit longer with us to get through everything, answer all these questions. I don't specifically see too many more questions, but if they do come up, I'll send them your way. So before we wrap up, where can people go to learn more about the work you're doing or the Zero Energy Ready program if they want to?
Yeah, all you have to do is just Google DOE Zero Energy. There's the website. You got it right there in the screen.
Yeah.
But you can just Google DOE Zero Energy Ready Home Program, and there is gajillion of information in there. You have my information. You can either email me or call. You can go to my website. I don't keep it up as good as I should, but there's a lot of good information in there. So
yeah, great. Well, Armando, I really appreciate your time. And like I said, maybe we'll have you back out just to talk about your approach to design and building and what you do, because I think a lot of people just genuinely want to hear more. So maybe we'll have you back out to talk a little bit more. But again, thank you so much. Thank you all for joining us. We'll be off next week for spring break, and then we'll be back again the following week. So take care, and thanks again,
Thank you,
everybody.
Brett, and thanks everyone for putting up with me for 2.5 hours.
All right, goodbye.
Okay, thank you.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.